So this is 3, 6 first, which is polynomial and rational inequalities. So we're going to go back to solving inequalities, finding the domain of a function, interval notation, all that fun stuff. And of course, solving quadratics, factoring polynomials, graphing, we could do a lot of different things with this. So let's start off with older stuff. Find the domain of f of x. So how do you find the domain of a radical function like this? What do you do? Stare at it. Okay. Oh, we're going to have to work on that mathematical skill there. What if it was the square root of x plus 2? How would you find its domain? Set it equal to 0?
No.
What can't go under a radical? Negative number, so we want to force it to be. So how do you mathematically force something to be positive? Greater than or equal to. So you take the inside stuff, like normal, and you would write x squared minus 5x minus 6, and we want to force this thing to always be positive. So we want to choose x values that force that thing to be a positive value. Okay. Now, this is a little different than linear. Linear is easy. If you have 2x minus 3 is greater than or equal to 0, you're going to get x is greater than or equal to 3 halves. 3 halves to infinity. That's simplistic. But that's linear. Linear is nice because it's either always going up or always going down, or it's very boring and flat. This is a quadratic. And if you remember quadratics, they look like parabolas. And there's 3 places the x-axis could be. The x-axis is here. The parabola is always going to be positive, always greater than or equal to 0. If the x-axis is here, it'll be 0 at one point, but the rest of it will always be positive. But if the x-axis is here, then you have this little portion of the graph that is negative, and you have these 2 branches that are positive. And I need to be able to find these rather quickly. So one method to do it is, well, if this was an equation, what would be your first step? No, that would be the last thing I would ever do. What would be my first thing I would ever try? Factoring. So factor it. What are factors of 6 is subtracted to 5?
X minus
1 and 6, right? So it would be x1 and x and 6. What kind of 6? What kind of 1?
positive 1, negative 6.
Positive 1, negative 6. Now, I know what the zeros of this. In other words, I know where this thing is crossing the x-axis. It's crossing at negative 1 and at positive 6. My problem with a lot of these is not knowing if it's going, the way it's showed here, the u, or if it's upside down. And some of these polynomials are going to get rather messy, so I want to come up with a technique that always works. And the technique that comes in handy is what I call the number line technique. And if you get into higher levels of math, this technique actually comes in really handy because it takes really complex stuff and makes it rather, simple. And the reasoning behind this is the behavior on these intervals is going to be constant for the entire interval. In other words, from negative infinity to negative 1, this graph is going to have one behavior because it only has that one x-intercept. So it's not going to cross the x-axis anywhere to the left. Same thing for the in-between and same thing to the far right. So the trick works this way. Pick any number you want to the left of negative 1. Negative 2, negative 3, negative a million. It really doesn't matter as long as you pick it to the left. Most people say negative 2. Plug it into the 2 factors and see what happens. If I plug in negative 2 to the first one, you get negative 2 plus 1, which is what kind of number? Don't worry about its answer, just what kind of number. It's negative. It's negative. If I plug in negative 2 into the second factor, you get negative 2 minus 6 makes it a negative. And a negative times a negative is a positive. So this thing actually is greater than or equal to 0 on that interval. Okay? Pick a number between negative 1 and 6. 0 is a good one. If you plug in 0 to the first one, it's positive. If you plug in 0 to the second one, it stays negative. Positive times a negative is a negative. Oh, that doesn't work. That's not greater than or equal to 0. Okay. Pick a number bigger than 6. 10. If I plug in 10 to the first one, it's guaranteed to be, well, positive. 10 into the second one is also positive. So this one is the one I'm looking for. So when I say what is the domain of this function, it's whatever makes the intervals positive. So what intervals are positive? Greater than 6, interval notation. Start on the left, work your way to the right. Negative infinity, all the way to negative 1, bracket or parentheses. Can you take the square root of 0?
Bracket.
Yes, bracket. Also because the equals up here, greater than and or equal to. Union, what's the next interval? It doesn't work between negative 1 and 6, so it has to start at 6 and it goes off to infinity. So the domain of this graph is 2 pieces. The graph is kind of weird looking. It looks something like this. I'm not going to say it's perfectly like this. Has an x-intercept at 6, has an x-intercept at negative 1, and it looks like little devil ears. There's absolutely nothing in between negative 1 and 6. It's empty there. The only part of the graph it goes away in both directions. Kind of cool, huh? Of course, these things can get strange. For instance, what if I want to solve this inequality? 2x minus 1 times x plus 3 times x minus 4 all squared. Thank God I didn't expand it out and have you go through the rational root theorem and break it all down into its proper factors. I can ask that on the test, by the way. I'm just not going to do it here because it takes up too much time. So if I want to solve this inequality, I want to know what numbers that I can plug into this thing that force the answer to be what kind of number. Yeah, but what kind of numbers are less than 0? Negative. You really want to get the idea that you're looking for negative numbers in this one. Unlike the radical one over here where we wanted to force it to be positive or 0. All right, draw a number line. Since it's in factored form, you should be able to tell me what the zeros are. What are the zeros of that polynomial? One half, negative 3, and 4. So negative 3 is the farthest to the left, then 1/2, and then 4. You don't have to separate them out like on a number line, evenly space them and make it look nice. You can just put marks as long as they go in order left to right, you're perfectly fine. And then the technique just takes over. Pick a number on the first interval.
10.
10's over here.
Negative 10.
Ah, negative 10. So you want to go for negative 10. That'll work. It makes the first one negative. Makes the second one negative. Makes the third one positive. Why positive? Because of that square. The number on the inside is negative, but once you square it, it becomes positive. So be careful of that. So negative, negative, positive is what kind of number? Negative times a negative is a? And a positive times a positive is a? Positive. The trick is, I'm just going to write plus here for positive. The trick is, if it has an even number of negatives, it's positive. If you have an odd number of negatives, it'll be negative. All right, pick a number between -3 and 1/2. 0. If I plug in 0 to the first one, what kind of number do I get? Negative. Second one? Positive. Third one? Positive. So negative, positive, positive? It's a big fat negative. Okay. Pick a number between 1/2 and 4. 1. Plug it into the first one. What do I get? Positive. Second factor? Positive. Third factor? Positive. So this is definitely positive between 1/2 and 4. Pick a number bigger than 4.
6.
10. 4. 10. If I plug it into the first one, positive. Second one, positive. Third one, positive. No matter what I put in that third one, it's going to guaranteed be positive. So what's determining the sign is really the first two. So this is also positive. Okay. So which ones am I looking for? The negative ones. So I'm looking for between, oh, I should be careful with my symbolism. Brackets or parentheses? Parentheses. So I'm looking between -3 and 1/2. Where else am I looking?
Why would you do the negative infinity?
But it's positive going up to negative infinity. I'm looking for negative numbers.
So you just disregard it? Like forget?
But if I go to the left of -3, my answers are all positive. I don't want positive answers.
But if you do -4, it's still
Positive. You made me take -10 over here, remember? And it's positive. The only answers I want are the ones that are negative. So the only answer is -3 to 1/2. Done. See what I'm saying?
Yeah.
Okay. Let's switch markers.
So why would that be bracket? So you can't go past it?
It's not bracket because there's no equal sign. It's just strictly less than. Strictly less than. Let's graph this thing. What's the degree of this polynomial? 4. Yeah. 1 from him, 1 from him, 2 from him. That adds up to 4. End behavior of 4th degree polynomial that's positive. S's are for odds. This is even. Either both up or both down. So which one is this? Both up. So it's up on the left, up on the right. I'll just put it right on this number line. All right, so it comes down and goes through -3. How does it behave at -3? Bounce, level, through. Through. It's a linear factor. Doesn't do anything fancy if it's linear, so it just goes through. So the graph is going to come down and go through 3. Then what's it going to do? It's going to come down through 3. Eventually it has to, because it has to go through 1/2. Now, look at the factor of 1/2. Is it anything fancy? No, just go through it. So turn around, go through it. Then, what does it have to do? It's got to come to 4, but once it comes to 4, is it fancy? How fancy? It's going to what? Well, look at it.
A bounce, right?
It's got to bounce
Yeah.
because of that square. So you could come in early, bounce off the 4, and there you go. So the only time this graph is below the x-axis is between -3 and 1/2. The rest of it, it's above. All right, trick question. Let's add on one little piece of information. Let's do the same thing. 2x minus 1, x plus 3, x minus 4 squared. Let's make it less than or equal to 0. The solution to the one above was -3 to 1/2. The solution to this one is now what?
Greater than
It's still less than or equal to 0. It's strictly the same thing. All I did was add in the equal. What would be the solution to this one?
bracket of -3, bracket 1/2.
I'll give you that. Bracket -3, 1/2, bracket, union.
Would it make everything opposite?
No, all I did was include equals.
0.
Which one's equal 0?
0.
There's one more answer. There's one more thing that makes this thing equal to 0 besides -3.5. Four, all by itself. All by itself. It hits the x-axis right here at 4. It's equal to 0. So you have to kind of get that in your answer. Now, you can either do union bracket 4 by itself, or you can do union squiggly 4 by itself. Either one works perfectly fine. But that would be the solution to that inequality. What makes it equal to 0? -3, 1/2, and 4. What makes it less than 0? Between -3 and 1/2. Trick question. I love my trick questions. The same process works perfectly fine with rational functions. And this is our concentration for 3.5. So, for example, if you have, very good examples. X minus 3 squared over x plus 2, x minus 1. And I want this to be greater than or equal to 0. Greater than or equal to 0. So this is a rational function. What do you have to worry about with rational functions? Or rational expressions? What about it? Got to be really careful when it's equal to 0. So before you even start this, it would probably be really wise to go off to the side and say, x definitely cannot equal what? -2 and +1. So no matter what happens with this problem, I cannot include those two as part of my answer, because those are the ones that make the bottom equal to 0. All right. Then the rest of it is very similar. Draw a number line. Put the zeros of the function on the number line. Now, when I mean the zeros of this thing, it's a little different. It pretty much is what makes each one of the pieces equal to 0. Don't worry that 0 can't be part of the denominator. It's still going to be part of our number line. So what numbers would be on our number line? -2. 1. One more.
9.
No.
-3.
3. It's what makes the top equal to 0. So the first two numbers are what make the bottom equal to 0. They're the ones I have to throw out at the very end of the problem. The top one is what makes it equal to 0 is at 3. All right, and then you just test the intervals. Pick a number somewhere to the left of -2. Don't say it. -10. -10, fine. If you plug in -10 into the top, what does it make it?
A lot.
Oh, I don't care what the number is. All I care if it's positive or negative.
Positive.
It's positive because it's being squared. So the top is going to become positive. What about the bottom two pieces? Now remember, it's -10. So negative and negative. And a positive, negative is a positive. So anywhere to the left of -2, this thing is guaranteed to be positive in value, graphically above the x-axis. All right, pick a number between -2 and 1.
0.
0. If you plug in 0 to the top, it becomes positive. 0 for both of the bottom pieces, a positive and a negative. So that forces this to be negative. All right, number between 1 and 3, 2. Plug in 2 to the top, it becomes positive. 2 to the first piece, positive. 2 to the second piece, positive. So this is guaranteed to be positive between 1 and 3. All right? Pick something bigger than 3. 6. If I plug it into the top piece, positive. The x plus 2 piece, positive. The x minus 1 piece, positive. So this is, again, positive. Great. So, what is the solution to the intervals that I need? Now, remember, go back to this. What does this mean in English? Positive or 0. Either one works perfectly fine. Positive or 0. So what's the first interval I want? Negative infinity. Up to? Positive 2. Negative 2. Parentheses or bracket? Why? Thank you. Because it can equal negative 2. Even though the inequality has an equal, we can't have negative 2 part of it because if you plug it in, it becomes 0 in the denominator. Union? Where else? 1. Parentheses or bracket? Parentheses. 1 up to?
Infinity.
Infinity. Why not? Why didn't I stop at 3? Well, that and 3 makes it equal to 0, which is perfectly fine. So you'd get to 3, but then you'd start again at 3, so you might as well just get rid of the 3 completely. Writing this is irrelevant. Because this can be combined to be just 1 to infinity. Because those 3's are exactly the same. And they're both brackets. Alright, so the solution to this problem is these intervals, is what makes it positive or 0. Not that hard, right? That's all it is for 3-6. Same thing over and over and over again. If it's not in factored form, you have to put it in factored form, and then just do a number line test on